Hello everyone, this is Teacher Marge and welcome to our maths lesson video. Today's topic is about finding the area of composite figures. Be sure to have a pen and paper so you could write down your computation for each figure that I will be presenting in this video. Before we can compute for the area of any given figure, it is important that we are familiar with the following terms. Area refers to the space or surface covered by a plane figure. It is always measured in square units. In the metric system, the fundamental unit for area is the square meter. A plane figure is a flat, closed figure that is on a plane. We usually call a plane figure as a shape. A polygon is a closed plane figure bounded by line segments. A circle is the set of all points in a plane that is the same distance from a given point. That given point is called the center of the circle. A semicircle is simply a half of a circle. A composite figure is a two-dimensional figure made up of two or more basic plane figures. Aside from these key terms, knowledge about the area formula for each basic plane figure is required to proceed to today's lesson. Can you match the shape with the area formula? You have 20 seconds to do so. Your time starts now. Time's up. Let's see if you got all correct. Keep in mind that these area formulas are very important in finding the area of composite figures. Let's have our first composite figure. Can you tell how many square units are there in this figure? By simply counting the square units inside the figure, we can say that the area of this figure is 27 square units, or 27 units squared. How about this figure? Counting the square units inside it will not guarantee that the area we'll have is correct. So what should you do then? You may pause this video to give yourself time to think, what are you going to do to get the area of this figure? There are two basic shapes in this figure. Can you identify the shapes? Yes, we have a rectangle and a triangle. To compute for the area of this composite figure, we need to get the area of each shape first. Let's start off with the rectangle. To compute for the area of the rectangle, we need to get the length and the width. Our rectangle is 5 units long and 3 units wide. Using these values for our formula, length times width, we'll have 5 times 3. And so, the area of our rectangle is 15 square units. Now let's compute for the area of the triangle. We need the measures of the base and height of the triangle as suggested by our formula. This triangle is 3 units long at the base and is 4 units high. Using these values for our formula will give us 1/2 of the product of 3 and 4. That means the area of this triangle is 6 square units. Now we're ready to find the total area of the composite figure. The area of the whole figure is the area of the rectangle plus the area of the triangle. That will give us 15 plus 6. And so, the area of this composite figure will be 21 square units. How about this figure? It would be helpful if you could identify first the basic shapes that make up this figure. You can pause this video to give yourself time in answering the activity. Let's start with the 5 by 5 square in this figure. The formula for finding the area of a square is side times side, or S squared. Using the values for the side, we'll have 5 times 5. And so, the area of this square is 25 square centimeters. The upper portion of this composite figure is a parallelogram that is 12 centimeters long and 3 centimeters high. To compute for the area, we will use the formula area equals base times height. Then substituting the values for the base and height, we'll have 12 times 3. And so the area of this parallelogram is 36 centimeters squared. Now we are ready to compute for the area of the entire composite figure. The area of this figure is equal to the sum of the area of the square and the area of the parallelogram. The area of the square is 25 centimeters squared, while the area of the parallelogram is 36 centimeters squared. Adding these two areas will give us 61 square centimeters. Can you compute for the area of this figure? Pause the video to give yourself time in answering the activity. The upper part of this figure is a semicircle, while the area of a circle is equal to pi times r squared. The area of a semicircle would be half the area of that circle. That means our formula for the semicircle will have to be A is equal to 1/2 pi r squared. Substituting the value for pi and the radius will get us 1/2 times 3.14 times 10 times 10. And so, the area of our semicircle will be 157 centimeters squared. Let's now have the lower part of our figure. This figure is a triangle, and the formula for finding the area of a triangle is area equals 1/2 the product of the base and the height. The base is 20 centimeters long, and the height is 25 centimeters. But why do we have 20 as the base? You see, the radius in our figure is 10 centimeters, and it is just half the base. That means we'll have another 10 centimeters to complete the base. Adding these two will give us 20 centimeters. And so, the area of this triangle is 1/2 times 500, which will give us 250 centimeters squared. Now let's have the area of the entire figure. The area of this composite figure is the sum of the two areas. The first area being 157 square centimeters and the second area as 250 square centimeters. And so, our total area for this composite figure will be 407 centimeters squared. Remember, whenever you are computing for the area of any given composite figure, it is very important that you identify first the basic shapes that make up the composite figure and determine the dimensions you need to compute for the area of each basic shape. Then, compute for the area of each basic shape. Finally, get the sum of the areas of the basic shapes in the composite figure. I hope this video lesson will help you in answering the activities in your module. This has been Teacher March saying thank you for watching and God bless. See you next time. Bye!